In this video, we're going to look at the different ways you can express linear inequalities. So a linear inequality is just simply a statement that one thing is greater than or less than another. And usually you start with an English inequality, an inequality written in English, and then you convert it into its different mathematical forms. So here we have x is greater than a. And notice if it says x is greater than a, that means that x cannot be a. That's one of the implications. So a forms a boundary on the real number line. So if I'm going to convert from inequality notation to number line notation, I'm going to go over to a, and I'm going to put an open circle at a, or a parentheses at a that's opening in the direction that x needs to go. And because x is greater than a, x needs to be moving this way towards positive infinity and away from negative infinity. So I would say the boundary is a, open circle, and to be greater than a, I have to be to the right of a on the number line. So an open circle and an arrow to the right, or a open parentheses facing to the right and an arrow pointing to the right. I like to use the open circle myself. I think Alex uses the parentheses notation. In interval notation, what we're going to say is that we're starting at a, and we'll use an open parentheses to indicate that we don't include a. We're starting at a, and we are moving towards positive infinity, but you can't get to infinity, so I'll use an open parentheses here, indicating that infinity is a place we can't get to. If you want to include a value, so if we were letting x equal a, then we would use a square bracket instead of an open parentheses right there. So in interval notation, this would say start at a but don't include a and go to infinity. That's how x can be greater than a. And then sometimes, depending on the instructor or the software platform, because you're using x, you actually need to use x is an element of. So the symbol right here means is an element of, or x is in, and then you could say x is an element of, or x is in the open interval from a to infinity. Set notation happens when we enclose things in curly braces. Interval notation is some combination of things being held together with either square brackets or a combination of square and parentheses. So there's like 4 different ways you can combine parentheses and square brackets. So in set notation, here's what I would write. I would write the set, and that's how you read this first opening bracket, the set of all x such that, so a vertical bar here means such that, and then you just come over and grab the inequality notation. The set of all x such that x is greater than a. And there's an alternative notation for the vertical bar. Sometimes you'll see such that written using a colon. So this would be the set of all x such that x is greater than a. X is greater than or equal to a. X is greater than or equal to a. This time, because I can include a, because x can be equal to a, I would put a solid dot at the boundary point a. And to be greater than a, I have to move towards positive infinity, and then alternative notation would be to put a square bracket opening towards infinity with the arrow. I prefer myself the solid dot. I think Alex uses the square bracket right there. So here's on the number line. In interval notation, I could say x is an element of, and these two are the same except now x can equal a, so I would use a square bracket. X is an element of the interval from a to infinity, open parentheses here because you can't get to infinity, and in set notation it would be the set of all x such that x is greater than or equal to a. So again, in set notation we just come over, grab this, plop it in. X is less than a. I guess I should write it in the box I wrote for it. X is less than a. And I said x and wrote a. X is less than a means a is the boundary, but because x cannot equal a, I'll put an open circle And to be less than a, I have to be moving on the number line towards negative infinity. I have to be below a to be less than it. And the alternative notation to indicate that the boundary is at a, but a isn't included, would be to put the open parentheses right here, opening towards infinity. Again, I prefer the open circle notation. In interval notation, I would say x is an element. And now on the number line, I'm moving from left to right. I'm starting at negative infinity. Negative infinity isn't a number. You can't get there, so open brackets so I don't include it. Running all the way up to a and not including a. And you always want the numbers to go in ascending order from left to right. In set notation, I would just write the set of all x such that x is less than a. X is less than or equal to a would be x is less than or equal to a. Now x is equal to a, so I would put a solid dot. And to be less than a, I need to move towards negative infinity. The alternative notation would be to use a square bracket opening towards negative infinity. Again, I prefer putting a point on the number line. And then in interval notation, I would have x is an element of, I'm still on the leftmost direction, I'm starting at negative infinity, so in ascending order, going from negative infinity, open parentheses not to include it, all the way up to a, and then I would do a square bracket to indicate that a is included in the solutions because we're told that x can equal a, and then I would say the set of all x such that x is less than or equal to a. Here x is less than a or x is greater than b. So x is less than a or x is greater than b. So in this case, we'll just keep the or. We could replace the or with the union symbol, which means combine the two things. But I'm just going to use the word or here. So to be less than a would mean don't include a. And to be less than a, x would need to move in this direction towards negative infinity. And here, with x greater than b, we would have an open circle. But to be greater than b, we would be moving this way. So notice with this or notation, and this is usually the case with or notation, there's usually a missing piece in the middle that's not included in the solution set. So we have what are called disjoint sets. They don't have anything in common. To be less than a or greater than b, well, there isn't anything that can be both of those things at the same time. There are other situations that arise with or, but this is the one that in practice shows up. In interval notation, I would say x is an element of, and I would start from negative infinity and run up to a. Because x isn't equal to a, we wouldn't include a, and then we would use the union symbol, which combines two sets, and we would union it with the other set, which starts at b and runs up to infinity. And in interval notation, in set notation, I would just go the set of all x such that, and then I would pop this stuff right here in x is less than a or x is greater than b, and it would be okay to replace the or with the union symbol if we wanted to. So we could do something like this. X is greater than or equal to a. So here I have x is greater than or equal to a, and I have an and statement, which is very different than an or statement. And means the two things have to be true at the same time. So and x is less than b. So if I do this, I get a has to be greater than or x has to be greater than or equal to a. So a solid dot at a. And x has to be less than b. X doesn't get to equal b, so an open dot at b. And what I want to notice is that to be greater than a, I would be going this way. But to be less than b, I would be going this way. And with an and statement, 19 times out of 20, what you're after is the overlap between those two lines. So to be greater than a means to move to the right on the number line. And to be less than b means to be to the left of b on the number line. So for the solution, we actually get just the line segment between a and b. And like I said, 19 times out of 20, this is what you get. With an OR statement, you get two disjoint, non-overlapping sets of things. And with an AND statement, we get a single line segment on the real number line. In interval notation, then I would say, lost my cursor for a minute. I would say x is an element of, and I'll use a square bracket because we start at and include a, and we run up to b, but we don't include b. And in interval notation, I would say the set of all x such that, and I want to notice that if I have an AND statement, I can actually put these together because x is greater than or equal to a and x is less than b can actually be combined here into a single sentence, because what you can see is that the x is between these two, so we can rewrite this actually as an inequality that looks like this. A is below or equal to x, and x is below or less than but not equal to b, and we can compact it into a single sentence. And like I said, 19 times out of 20, with an AND statement, we're going to be able to compact it into a single sentence like this. So a is less than or equal to x is less than b, and that's the inequality in set notation.